In this section, we'll build another Ionic app, and this time it will be a non-trivial example. We're going to develop a biorhythm calculator, and to show you what that means, I'll use this online calculator from Casio. To calculate the biorhythms, we first need to know the person's birth date. Let's say somebody was born on the 1st of January 2000. We also have a target date below, that is today, the 17th of March 2020. Now, if we click Execute, this will calculate some numbers and plot a graph. The idea behind biorhythms is that each person's abilities go up and down over time, but following some predefined cycles. For example, if we take the physical well-being, that is the blue line, you can see that it peaks at this point, that is around the 25th of March. So somebody born on the 1st of January 2000 will be at the top of their physical form on the 25th of March 2020. Their next peak will be after 23 days, that is around the 17th of April, and this cycle goes on forever. So on the target date, that is the 17th of March, their physical ability will be at this level, that is pretty low. And it corresponds to this number, minus 0.5 something, because minus 1 means the rock bottom and plus 1 is the top. Now, just to be clear, this theory about biorhythms has no scientific value. It's a bit like astrology. Some people believe in it, but it's just pseudoscience. But it should be quite a fun exercise to develop our own biorhythm calculator and run it as a mobile app. Also, it will allow us to learn a number of new things. We'll make use of some additional Ionic components like input fields that will need to let the user enter their birth date, for example. We'll also create a few React components of our own, and we'll see how to style individual components. Then we'll briefly cover writing unit tests that will be useful to make sure we calculate the biorhythms correctly. We'll want to store some data to remember some user settings, and we'll use local storage for that. And like any non-trivial project, we may want to use some additional libraries, for example, for working with dates, and also for displaying charts. One of the advantages of using Ionic is that it's based on web technologies, so we can use pretty much any JavaScript library that works in the browser. Now, let's go and set things up. Just like with the first example, I'm providing you with an initial project as a starting point. I'll just copy the project name from here, so I don't have to type everything. Now, in a terminal, I'll go into my projects folder, but you can use a different location on your machine, of course, and run npx degit gitlab ionic-react-course / biorhythm calculator, and put it into a folder with the same name. Then we can go into that new folder and open the project in Visual Studio Code. Just like our first example, this project was initialized with create React app, but this time I already added Ionic React and Ionicons to the dependencies. Also, if we look at index.js, here I've already imported all the Ionic CSS files. And finally, if we look at app.js, this already has the basic structure of an Ionic app, with Ion app, Ion header, Ion toolbar, and so on. So we're basically starting from where we left off in the previous example. Now, as usual, we'll need to install all the dependencies, so run npm install and wait a minute or two. Okay, now that we have all the npm packages, we can start our app by running npm start and wait a little bit more for the Webpack dev server to start up and open our app in the browser. Okay, so this is our initial Ionic app. We are developing for mobile, so enable device mode. And let's keep the editor and the browser side by side as usual. All right, we're ready to start adding some functionality, and we'll do that in the next video. So we have this initial Ionic app set up and running. Now let's start implementing our Biorhythm Calculator functionality. To begin with, we can change the title to say Biorhythms. I hope I spelled it right. Next, we want to add some real content. But what should we add here exactly? Let's have a look at that online Biorhythm Calculator. Here it's asking for a birth date and a target date. So we'll certainly need some input fields. If we search the Ionic docs for IonInput, we should find the right Ionic component. It should be the first result. As usual, the documentation page shows a preview with some input fields, and we can look at the usage to see some code. Seems like the most basic way to use this component is to simply write an IonInput tag without any properties. So let's try that in our own app. Let's put an IonInput inside IonContent, auto-import it, and just close the tag. Now, there's nothing visible in the page, but if we click at the top, you can see that there is actually an input field here, and we can type something in it. But obviously, if it's not clearly visible, that's not very good. To improve things, we could add some placeholder text, maybe, saying your name. So at least now there's some indication that the user should enter their name here. Still, we could do better. It would be nice to display a label before the input field. The best way to do that is to first add an IonItem component. That's simply a container for other components. Then we can move the IonInput inside the item. And now, let me collapse the imports so we can see the code better. Now, inside the IonItem, we can add an IonLabel component with the text of the label, say name. And you can see the result in the browser. So we use the IonItem component to group the label and the input field. Since we have a label now, we could remove the placeholder text. And it's worth mentioning that an IonInput can have a type, just like a regular HTML input element. And the type can be any of these values. That's a subset of the HTML5 input types. If we don't specify a type, then it defaults to text, which is the most commonly used. But of course, we can choose a different one, like password. That results in the text being masked when the user types something. Or we could use email, for example, which is very similar to text, but with email, mobile browsers will display a soft keyboard with letters more appropriate to type an email address rather than generic text. Anyway, let's go back to text since we're asking for a name. In fact, since it's the default, we might as well remove it. Now, we have an input field, but how do we make use of whatever text the user enters into the field? Let's add a simple paragraph here. Let's say we simply want to display whatever name the user entered. How do we do that? Well, pretty much in the same way as we would do it in React with a standard HTML input element. First, we need to import the useState hook, and then we can use it to get a state variable, let's call it name, and a setName function to update it. This is by calling useState, and we can pass an empty string as the initial value. Now we can use this name variable and display its value in this temporary paragraph. And we can also set it as the value of the input field. If we save at this point, well, name will always be an empty string, but if we change the initial value, you can see that both the input field and the paragraph below display Alice as the name. But we don't want to hard code a name, we want to know what the user types into that field. With a regular HTML input element, we can listen to the onChange event and pass an event handler that is a function that receives the event as a parameter. And here we can update the name to be event.target.value. Event.target is the input field, so its value will be whatever the user entered. This is the typical way to have a controlled component in React with hooks. So you might expect the IonInput component to work in the same way, right? However, this is not actually the case. If we enter some text into the input box, the value displayed in the paragraph below does not change. So this is a bit surprising. But the solution is actually very simple. Instead of the onChange event, we need to listen to the onIonChange event. This is because IonInput is not a simple HTML input element, but it's a more complex component, so the Ionic developers had to create their own event. If we look at the event object received here, it's now of type custom event. And this also means that instead of event.target, here we should use event.detail, because a custom event has a detail object. But if we save now, with this small change, you can see that the value of our name variable updates as soon as we type a character, or even if we delete something for that matter. So there is this small gotcha when using the IonInput component, that we must be careful to use onIonChange and not onChange. In general, it's always a good idea to look at the documentation page for each component. All events are documented there, and if there is an event called onIon something, you should be using that one instead of the usual one emitted by native HTML elements. But with this small caveat, using an ionic input field is very similar to using any other input element in React. In the previous video, we added an IonInput component, and we've seen how to bind the user input to a React state variable. We've also seen that we can use an IonItem component to group an input field and its associated label into a single row. Now, let's duplicate this item to see what happens if we have more than one field. In fact, in addition to the name, we'll need the user's date of birth in order to calculate their biorhythms. Now, let's leave this IonInput here, but without binding its value. Let's just focus on what it looks like for now, not on the functionality. If we apply these changes, we can see the new field row with the date of birth. But if we type something into both fields, anything will do. Notice how the values we entered are not aligned. Each input box appears right after the label, and since date of birth is longer than name, then the second value is displayed more to the right compared to the first value. Now, there's an attribute we can set on an IonLabel called position, and its possible values are fixed, floating, or stacked. There's actually a fourth possible option that is not setting the position at all, and in that case the label is displayed inline, which is what we've seen so far. But let's try fixed now, and we'll want the same position for the other label as well. If we enter something now, you'll see that both values are vertically aligned, one below the other. That's because each label takes a fixed amount of space, so the name label is the same length as the date of birth label. Okay, so that's what fixed does. What about floating? It looks the same initially, but when we select an input box, you can see that the label shrinks and it stays above the user entered values. So there's this little animation effect. Finally, let's try out the last option as well, that is stacked. In this case, you can see that the label is already above the input field in smaller text, and it always stays there. So we have a few options when it comes to positioning field labels. Which one to use is a matter of preference, but it's worth keeping in mind that when developing mobile apps, the space on the screen is limited. And if we choose fixed labels, that may limit the amount of text the user can see. Imagine if somebody has a fairly long name, it may not all be visible in this input box. So personally, I tend to prefer stacked labels because they allow more space for the input itself. Of course, it depends on what your specific fields do. I'm talking in general here. Floating labels also allow the same amount of space, but I don't particularly like that they move when you select the field. It's a nice animation effect, but it may be a bit surprising for the user. Anyway, this is just my personal view. You know what the options are now, and you're free to use whichever you like the most, of course. We recently added a second input field to our app to capture the date of birth that we'll need to calculate the biorhythms. At the moment, this is a text input, so the user can enter whatever they like. How do we make sure they enter a date, and in which format should they write the date anyway? A regular text field is not actually the best interface for entering a date. Thankfully, Ionic has a component for that. If we search the docs for IonDatetime, we can find the right page. Let's have a look at the preview on the right. To select a date, we're presented with like 3 spinning wheels where we can pick month, day, and year. This works like the native date pickers provided by Android and iOS. And it's a sort of user interaction that works well on mobile, where the screen is small, but users can touch the screen to spin the wheel. So let's see how we can use this component in our own code. Instead of an ion input, we can simply write IonDatetime, import it, and that's it. Let's try it out. Again, we can pick some month, day, and year, and the selected date appears in the field. Pretty simple. Now, this currently shows month, day, and year in that order, which is the format commonly used in the US. If you live somewhere else in the world, you might find this format unusual. That's one of the tricky things when working with dates. Different parts of the world use different ways to represent the same date. This page is from Wikipedia, and if we scroll down a bit, there are 3 main varieties. Big Endian, that is year, month, day, Little Endian, that is day, month, year, and Middle Endian, or month, day, year. So how can we display the date in whatever format is most familiar to our users? If you target US users, you're in luck, because as we've seen, that's the default format. But with the IonDatetime component, we can easily specify a different format as well. We can pass a string with the format using these groups of letters to represent different parts of the date, like year, month, and day. For example, if we take the month, we can write a single capital M to have the month represented as a number from 1 to 12, 2 capital M's for a number that's always 2 digits, so it will show 01 instead of just 1. 3 capital M's result in a short name like Jan for January, and 4 capital M's will give you the full name like January. Right, let's see how we can use this format in practice. We want to set a display format attribute, and the value will use those special groups of letters we've just seen. For example, 4 capital Y's minus 2 capital M's minus 2 capital D's should give us the ISO format. That is, we have year, month, and day all written in numbers. Also note how the month and day are always 2 digits, so they have a leading 0 if necessary. After we select a date, we can see it represented in the exact string we wanted, that is, with year, month, and day separated by a minus sign. So the display format is used both for the spinning wheels in the date picker and for the string displayed after the user made a selection. Now let's try a different format. Say we want the day, the full month name, and the year, as is frequently used in Europe, for example. If we try now, we can see the day first, possibly in a single digit, then the full name of the month, and it will get truncated if it's too long, and finally the year. So this is nicer in the sense that we see the full month name, but it's annoying that it can get truncated, so let's try the short month name instead. This time you can see that the month is always 3 letters, which always fits the space available. So I think I'll use this format, but feel free to use whatever format is most familiar to you if you're following along with this example. Now let's talk about how to use this date. Just like with the name, let's start with a temporary paragraph where we simply want to display the selected date. This will be very similar to what we did for the name. I'll collapse this header since we're not going to touch it. So we'll want a new state variable, let's call it birthDate, and a setBirthDate function returned by the useState hook. Now here we can pass an initial value, but what kind of value should it be? Should the date be a string? Or maybe it should be a JavaScript date object? What's the best data type for this value that will be used by the IonDatetime component? Let's have a look at the Ionic documentation again. If we scroll down a little bit, there should be something about the data type. Here they basically say working with the JavaScript date object is a pain, so we decided to use ISO strings everywhere to represent dates, which I think is a very good decision. Now, if you don't know what the ISO format is for a date, here are a few examples. If we want just the date, not the time, then we write year, month, and day, all in numbers and separated by a minus sign. If it's not just the date, but has the time as well, then you add a capital T to separate the time part from the date part. Then you have hours, minutes, and seconds separated by a colon. And finally, you can have the time zone offset as well. Now, there's no need to memorize this format, but it is an international standard and there are tools that make it easy to work with this sort of strings. So, back to our code. The question was, what should be the initial value for our date? Now we know that we can use a string. It will be an ISO date string, but it's still a string in JavaScript. As an example, the ISO string will be like 2020-01-31 to mean the 31st of January 2020. Now let's use this birthDate variable. Let's display its value in this paragraph and set it as the value of the IonDatetime. If we save at this point, you can see that the IonDatetime component is displaying 31st Jan 2020, following the display format we set, while in the paragraph below it just shows the original value of the string, exactly like we pass it to useState. Next, let's handle the event fired when the user selects a date. And this is called onIonChange, just like on an IonInput component. The only difference is that in this case we want to call setBirthDate and not setName. Let's save this and test it. We can select some date, and you can see that the value in the paragraph has updated as well. Interestingly, it has not just the date, but the time as well, even though all the time elements are zeros. Now, what if we don't want any specific date as the initial value? Well, we can just pass an empty string. That will tell the IonDatetime not to display anything to begin with. When the user opens the date picker, it will default to the current date, that is today, which is fine. In fact, if you look at the value in the last paragraph, it also has a specific time set. So it defaults to now, basically, the current time whenever the date picker was opened. Again, this is not a problem, but obviously we'll want to format the date in a more user-friendly way and not just display the raw ISO string directly. And we'll take care of that in one of the next videos. In the previous video, we started using the IonDatetime component. Now that we have a better idea of how to use some form inputs with Ionic, let's think a bit more about the user interface of our Biorhythms app. If we take this online calculator, we can enter a birth date. The target date defaults to today, so we don't need to change it. We click execute and we get some numbers with the physical, emotional and intellectual biorhythms. So we'll want something similar in our own app. In particular, we'll want to display these results somewhere on the page, maybe in some kind of container where they stand out a little bit more. If we look at the components provided by Ionic, there is something called an IonCard. If you look at the preview in the phone frame, a card is a container used to display some sort of information. It has a little border around it. It appears slightly raised thanks to some shadow, so it seems like a nice way to make some content stand out a little bit. Let's see how to use it in our app. Before we start, I want to clean up this user interface a little bit. We added those two paragraphs at the end just to show how to use values coming from input fields. Also, we don't really need to know the name of the user to calculate the biorhythms. We just need the date of birth. So let's simplify this example and remove the name altogether. I started with the name just to show you how to use a simple text input first, before introducing more complex components like the datetime picker. Let's save and check that everything still works. There's just an unused import somewhere. IonInput is no longer needed, of course. Okay, the name is gone. Let's remove this paragraph as well. And now let's see how to use an IonCard component. Make sure it gets imported. Inside an IonCard, we typically have an IonCard header. And inside a header, we can put an IonCard title. Let's just write the title for now. Then, after the header, we usually have an IonCard content. And here we can put whatever content we want. So that's what a very basic card looks like. If we want to center the text, we can simply add a CSS class called IonTextCenter. That's one of those CSS utilities we mentioned in the last section. And everything inside the card is nicely centered. So we're going to use this card component to display the biorhythm results. Instead of the title, we could display the current date maybe. That is the target date for which the biorhythms were calculated. And as the content, we could show a paragraph for each type of biorhythm, so physical and its number, just writing a mock value here, Then duplicate this line 3 times because we need emotional with some other number and intellectual with its own biorhythm value. Okay, let's see what this looks like in the browser. I think that's a good start. We can improve the appearance later, but we have an initial UI where to display the biorhythm results using an IonCard component. Okay, so we added a card component to our app and we'll use it to display the biorhythm results. Before we go ahead and calculate the actual biorhythms, I'd like to do some refactoring because I think the code of this app component is getting too large. We should really start splitting the code into separate components, starting with the new card elements we just added. So let's create a new folder inside source called components. And inside components, we can add a file called biorhythmcard.js. This will be a regular React component. Now, I have my own user snippet called react-fc that can generate the basic boilerplate for a React function component. So I'll just use that. User snippets are a feature in Visual Studio Code that allow you to quickly insert some code without having to type the whole thing. Maybe I'll add a link somewhere on how to create a user snippet, but you can just type the same code manually. For any React function component, you always need to import React, declare a function that returns some JSX elements, and export it. Now let's save this file and we'll want to import it into our app.js. So here we can add an import for biorhythm card that comes from a local module that is components biorhythm card. All right, now we can use this biorhythm card and we want to insert it in the same place where we currently have the IonCard. Eventually, it will replace the IonCard, but let's do one step at a time. In the browser, we can see biorhythm card in square brackets. That's the placeholder for the new component. Now we want to take all the code with the IonCard and move it to the new component. So I'll cut this code and go and paste it into the biorhythm card, replacing all the elements there. So this is what will be rendered as the biorhythm card. We just need to import all the Ionic components, otherwise we have some compilation errors. And I'll just use the auto-import functionality as usual. Okay, that should fix all the errors. Let me quickly split these imports into separate lines so it's easier to see each one of them. And that's it. If we save now, we actually see two cards. We still have the old card as well because I haven't saved app.js after removing the old code. So let me save this file as well, and now we only have the new biorhythm card on the screen. Good. If we check the DevTools, there are a few unused imports, which is to be expected. We need to remove all the Ionic components that are no longer used in this file. And that should make the warnings go away. So far we simply moved some code from the app component into its own biorhythm card component. Now let's think about which props we need to pass to this component. For a start, we display a date in the title, and we could pass that in as the target date property. Note that I'm using the object destructuring syntax here to extract the target date from the props object passed to this component. So once we have the target date, we can display its value instead of the mock date we have at the moment. And if we save, we don't see any card title anymore. That's because we're not actually passing a target date prop from the app component yet. So let's define a target date variable here. And we can set it to a new date that will be the current time, that is now. But we also want all dates to be in the ISO format, so we can call toISOstring to convert it. And with this, we can take the target date and pass it to the Biorhythm Card component as a prop with the same name. Okay, let's see if this works. There you go. We see the current date and time as the card title. Now, we're showing the ISO string directly, which is not very user-friendly, so we'll want to format this date more nicely, and we'll do that in the next video. What we've done in this exercise is create a separate component called Biorhythm Card, then import it and use it in our app component. And this shows that obviously we can have multiple React components in an Ionic app. Just like with any other React app, there's nothing special to Ionic in this regard. We are at a point where we can pass a target date to our new Biorhythm Card component, and it gets displayed as the title there. But displaying the date like this as an ISO string will be a terrible user experience. We'll also need to deal with dates to calculate the biorhythms. So we could really do with some helper library to make working with dates easier. We're going to use Day.js. There are quite a few different date libraries for JavaScript. Moment.js is a popular one, but it's also fairly big in size. So for this example, I chose Day.js that has a similar API but is a lot smaller. Let's go back to our editor and start by installing Day.js into our project. We'll need the terminal, stop the dev server, and then run npm install Day.js. Okay, now we have Day.js in our project. Before restarting the dev server, I want to show you a little bit how to use this library interactively. So I'm going to start Node as an interactive interpreter. If you run Node without any arguments, it shows a prompt where you can enter JavaScript code directly. I don't know if you ever used it like that, but I find it quite useful to quickly experiment with some code. So we're going to import the Day.js library by requiring the Day.js module. Node.js doesn't fully support ES modules yet. That's why we need to use the require function rather than an import statement. But apart from that, we can write regular JavaScript code here. So let's start by creating a variable now. That's the result of calling Day.js as a function. If we call Day.js without any arguments, it will return an object representing the current time. We can evaluate the variable, and you can see that it's an object with a number of fields, but it's not actually very human readable. So let's print out now to string instead. This looks better. It's the current date and time at the time I recorded this video course. Obviously, if you try it yourself, you'll see a different time. Now, we want to work with ISO strings, and there's also a toISOstring method that gives us a string in ISO format. The letter Z at the end means it's in the UTC time zone, in case you wonder, but we don't really need to worry about that. A Day.js object also has a format method that we can use to specify a custom format. This works pretty much like the display format we've seen for the IonDatetime component. If we want the day, the short month name, and the year, for example, we can pass this string. So we could use this method to format the date before displaying it to the user. What else can we do? If rather than the current time we want a specific date, we can call Day.js passing an argument, and this can be a date in ISO format. Day.js will parse it and build its own date object from it. Another thing we'll need to do when we get to calculating the biorhythms is finding the difference between two dates. So let's look at that. We still have our variable now that we can print out again. And this has not just the date, but the time as well. Ideally, we want the date without the time being 1742. We can use the start of method and pass an argument saying the start of what. So start of day should give us the same date, but with the time set to 0. This will be useful for our calculations. In fact, let's assign that to a variable called today, that is now, but at the start of the day. We can also manipulate a date by adding, for example, one day to it. And the result should be the 19th of February, because today is the 18th of February. Of course, we can add more than one day, and the second argument can be days in plural. It works in the same way. We can even add a negative number of days if we want to. Alternatively, we could use this subtract method. Finally, let's see how to calculate the difference between two dates. Suppose we have a date representing a month ago. So that would be, since today is the 18th of February, a month ago was the 18th of January. Let's print it out, just to show it's been parsed correctly. Now we can take today, that's the variable we defined earlier, and calculate the difference compared to a month ago. And we need to pass a second argument specifying which unit to use. And in this case, we want the number of days. The result is 31, which of course is correct because a month that includes the end of January has 31 days. To calculate biorhythms, we'll need the difference between the date of birth and the target date, so this method will come in handy. Okay, let's stop here for this interactive session and go and restart the React development server. We can now use this Day.js library in our application code. The dev server is up and running. Let's focus on our code again. We want to format the date displayed in the biorhythm card, so let's go and add Day.js here. We want to import Day.js from the Day.js module. And then we can add a function, let's call it formatDate, where we take a date as an ISO string and return what? We want to first pass the ISO string into a Day.js object, then we can call the format method and pass a format string with day, month, and year. I'm using exactly the same string I used for the IonDatetime component, so the user will see all dates in the same format. Now we can simply use this new function to format the target date displayed in the card title. And if we apply these changes, we can see in the browser that the date is a lot more readable now. So that's it for this video. What we've done shows that we can add pretty much any JavaScript library we want to our Ionic project. But especially when developing mobile apps, it's important to be aware of how much weight each additional library adds to your project. That's one reason why we chose Day.js for this example, because it's so small. And incidentally, if you want to learn more about Day.js, you can just look at its docs, of course. The homepage is day.js.org. We're using Day.js to format the target date that we display in the biorhythm card. It's now time for us to calculate some actual biorhythm results rather than displaying those mock numbers. So let's have a look at the online calculator again. Here we can enter a birth date, say the 1st of January 1995. We can leave the target date to be today's date, click Execute, and we get some numbers representing the physical, emotional, and intellectual biorhythms. We want to do the same in our app. So how can we calculate those numbers? If we look at the Wikipedia page, there's a calculation section where we can find some formulas. We'll basically need to translate these mathematical functions into JavaScript code. We'll come back to these formulas once we are ready to write the code. Let's set things up in the editor first. Let's add a new file at the same level as app.js. Let's call it calculations.js. And here we want to write a function to calculate a biorhythm. As parameters, we'll need the birth date and the target date. We'll return a number. Let's start by always returning 0. So this is just the stub of our function. Let's export it as well so we can use it in other files. Now, we could go on and write the implementation by translating those formulas we found on the Wikipedia page. But how will we know if our code is correct? How can we be sure that the number we're calculating is actually the right one and we didn't make a mistake somewhere? For this sort of functionality, it would be really useful to write some unit tests. So that's what we're going to do now. Let's save this file as it is and go and create a new file called calculations.test.js. Here we'll write the unit tests for the code in calculations.js. Now remember that this project was initially generated with Create React App, so the way it works for running tests is exactly as documented in the Create React App pages. In particular, it uses the Jest framework for the tests. We'll see how to write a test in a minute. Let's think about our test cases first. We're lucky to already have an online calculator that we can use as a reference. So we can say that we expect our code to produce the same results as this online calculator. In particular, if we calculate the physical biorhythm for somebody born on the 1st of January 1995 and for the target date of the 18th of February 2020, then we should get 0.5196. So that's our first test case. Let's go and write this into code. To begin with, we need to import the function we want to test from our new calculations module, and the function is calculateBiorhythm. Then we can define a new test using the it function that's part of the Jest API. Here we pass a description of what this test verifies, and we're calculating a biorhythm. Then we pass a function with the actual test code. And here we want to get the result by calling the calculateBiorhythm function. We need to pass it 2 dates, and we want to use exactly the same dates we used in the online calculator. So the birth date was 1995-0101, this is in ISO format, and the target date is 2020-02-18, right? Now we expect the result to equal the number we got in the online calculator. So let's copy the number for the physical biorhythm, and we expect our result to be exactly the same. This way we'll know for sure if our code works correctly or not. Now, to run this test, we need to open a terminal. I'll stop the dev server, but you could also leave it running and open a different terminal if you want. Anyway, we can type npm test to start the test runner. If we look at the output, there's one test failing, and you can see that it gives you a very detailed explanation of why the test failed. In particular, we expected 0.5196, but we received a result of 0. Now, the test runner runs continuously by default, so we can keep editing our code, and as soon as we save some changes, the tests will automatically rerun. We can now go and implement the actual calculation to make the test pass. So let's go and have a look at the formulas again. These formulas all use a variable named t That's defined below as the number of days since birth. So that's the first thing we need to calculate, the difference between the birth and target dates. We can import our nice little Day.js library to help us with date calculations. And in this function, remember that we received the birth date and target date arguments as isostrings. So first we need to parse them into Day.js date objects by passing the isostring to the Day.js function. And I'm also going to use the startOf method to make sure we get the time at the start of the day, because we only want to work with whole days, not hours or minutes. Let's do the same for the target date as well. Pass it into a Day.js object and take the startOf day. Now we're in a position to calculate the difference between the target day and the birth day, calculated in number of days. So we have the difference. Now let's look at the rest of the formula. If we look at the physical biorhythm, we need to take t, that is the difference in days, multiply it by 2 times pi, then divide it by 23, and finally apply the sine function to the result. Let's see how we can translate all this into JavaScript code. The sine function is available as math.sine. Then we want 2 times the pi constant times the number of days since birth that we called diff and divided by 23. Is that correct? Well, we just need to save this file and the test will tell us. The test is failing. Let's go and check why. It failed because we were expecting 0.5196, but we got 0.519583 and many more digits. So actually the two numbers are pretty close. It's just that the expected result we copied from the online calculator is probably being rounded to 4 decimal places. This is a common problem when comparing floating point numbers. Let's see how we can tweak our test to be a bit more lenient when comparing numbers. Instead of to equal, we can use to be close to. So we're basically saying it's okay if there's a very small difference between the expected and actual numbers. And if we save now, our test is passing. Good. Now, so far, we only calculate the physical biorhythm. We also want the emotional and intellectual ones. We could have 3 different functions, one for each type of biorhythm. But since we're always going to use all 3 of them at once, I'm going to create a new function called calculate biorhythms, plural. And I copied the signature from the other function because we'll still need birth date and target date. Here we're going to return all 3 values at once, so we can return an object with a physical property, that's some number, then emotional, that's another number, and intellectual, again with its own value. So that's the stub of our new function, and we won't be exporting this other function that calculates a single biorhythm. We want external code to only use calculate biorhythms. If we save now, our test will fail because it's still calling the old function. So let's update this test to calculate biorhythms, plural, and the result will be an object that we can destructure to extract just the physical biorhythm for now. That's the one this test is verifying. Now, the test still fails because the received value is 0. Incidentally, note how, since we're using to be close to, there's this additional message saying that the difference must be less than 0.005. That's the default tolerance used by to be close to. Anyway, to make this test pass again, we need to update our calculate biorhythms function to return a real biorhythm value. Now, all biorhythms are calculated using a similar formula, except for this divisor number here that is 23 for the physical biorhythm, but some different values for emotional and intellectual. Let's make this function more generic by passing in this number as a parameter. I'll call it cycle. So we divide by the cycle, and now we can set the physical value by calling calculate biorhythm with the birth date, target date, and the cycle, that is 23. And our test is passing again. All that's left is implement the other two biorhythms. But before we do that, we want to create some additional tests to make sure our calculations are correct. So we want a test for the emotional biorhythm and another one for the intellectual biorhythm. Of course, we'll also need to check for the correct numbers. So let's go back to our online calculator and copy the value for emotional, paste it as the expected value of our second test, and then repeat the exercise for the intellectual value as well. This is 0.8 something. Save, and 2 tests are failing, 1 passed. This is expected. If we check the details, the physical biorhythm is green, emotional and intellectual are red. That's just because we haven't finished our implementation yet. Back to our calculations. The emotional biorhythm will be calculated exactly like the physical one, except that the cycle is 28 days. You can look this up in the Wikipedia page. Ditto for the intellectual biorhythm. That cycles every 33 days. If we're lucky, this should fix all the tests. Yes, it does. And thanks to these tests, we can be confident that the numbers we calculate are actually correct. We can run these tests again at any time to make sure we don't break something when we make changes to our code. And it's an automated process, meaning that we don't have to start the application and test it manually by interacting with it in the browser. Writing unit tests is a very good practice, and I strongly encourage you to try it if you're not doing it already. We won't actually write many tests in the rest of the course because it does take time and there are many other things we want to learn about Ionic. But I wanted to show you that you can absolutely write unit tests in an Ionic app, just like with any other React app. Okay, we wrote the logic to calculate the biorhythms, and we have some tests to verify that the logic is correct. Now let's go and display these biorhythms in the user interface. I'm going to stop the test runner with Ctrl+C and then start the React development server again. We don't need these tests anymore, and I'll just rearrange these windows a little bit while the dev server starts up. Okay, now that it's up and running, we want to display the biorhythm results in the biorhythm card. So in this component, we can import the function to calculate the biorhythms, and it's in calculations.js that's in the source folder. So it's in the parent folder compared to where components are. And the function is calculate biorhythms. Now we can call this function before rendering the user interface. And here we need to pass the birth date, but we don't have it in this component, so let's add it to our props. Let's update the app component as well straight away. Here we already have the birth date, we just need to pass it as an additional prop to biorhythm card and save this change. Now we can pass this birth date to calculate biorhythms along with the target date. And what we get as a result is an object from which we can extract the physical, emotional, and intellectual properties. Okay, Now that we have the numbers, we just need to display them, starting with physical, then do the same for emotional, and finally intellectual. Alright, let's see if this works. Interestingly, all the biorhythms now show none, that is not a number. This means the calculation failed, and that's because we haven't entered a date of birth yet. We'll need to fix this scenario, but let's try selecting a date now and see what happens in that case. Okay, we see some numbers there. They do have lots of decimal places, and that doesn't look great from a UI point of view. So let's go and change that. We can use the toFixed method on a JavaScript number to limit the decimal places displayed. And we can show 4 of them, like the online calculator we used as a reference. Alright, let's try again. I'll just pick a random date. And it looks better now with 4 decimal places. Okay, we still need to handle the case where there is no date of birth yet. We don't want to display not a number to our users. I think the best way to avoid this situation is not to display the result card at all until the user has selected a date. So let's go and do that. The app component is where we include the biorhythm card. Here we can simply display the card conditionally based on the value of birth date. If birth date is truthy, which means it's not an empty string, then we display the biorhythm card. Okay, let's try this out. There's no card anymore, but if we select a date, then we see the card with the biorhythms. Good. I wonder if it actually looks nicer if we show the card above the date. Let's give it a try. I'll just move these lines above the ion item with the date field, and we'll find out. Again, there's no card initially, but after we select a date, we see the card at the top. I think it's better this way, because the user only needs to enter their date of birth once. After that, they'll just be interested in seeing the biorhythms, so it makes sense to display those first. Alright, I'll leave you with a simple exercise. At the moment, we're always using today as the target date. It would be nice to let the user select a different target date, like in the online calculator we've seen. You can try and do that yourself if you like. In any case, we'll see the solution in the next video. I left you with a small challenge, that is adding another field to let the user enter a different target date. So let's see how to do that. I'm actually going to change the position of this label to fixed, because the date is always a short string. There's no risk of it taking up too much space. But this was just an optional step. Now let's go and add another field. We can start by just copying and pasting the existing ion item block. Then we want to change the label to say target date. Next, we'll need to modify this event handler. We actually need to change this target date to be a state variable, like birth date. So we'll call the useState hook. Now, as the initial value, we may still want to use the current date, because it's a good default. If the user wants to see the biorhythms for today, they don't need to select a different date. Now we can use the target date variable as the value of the IonDatetime. And instead of set birth date, here we want set target date. That's pretty much it. We now have 2 fields for the 2 dates. If we pick a date of birth, let's change the year. We see the biorhythms for today. But if I want to know what my biorhythms will be next week, for example, then I can select a different target date. and see some different results. All right, that was pretty straightforward. In this video, we'll see how to use local storage to save small amounts of data in the client. At the moment, our user can select their date of birth and see today's biorhythms, but if they open our app again tomorrow, they'll need to enter their date of birth again. That's quite annoying because somebody's date of birth is always the same, of course. It would be nice for our app to remember it. The app component is where we capture the birth date. Could we store it somewhere so it persists across page reloads? The simplest way to store some data in a web browser is to use the local storage API. In the DevTools, we can see the local storage here. Each domain has its own storage that contains key value pairs, although this one is empty at the moment. Let's quickly see how to use it in the JavaScript console. There's a global object called local storage, and we can call the setItem method to save a value. For example, we could save something under the myVar key with a value of myValue. If we inspect local storage now, you can see that this time there is a row with myVar as the key and myValue as the value. To retrieve that value, we simply write local storage getItem passing the key that is myVar, and we get myValue as the result. So local storage is very easy to use and it's convenient for storing simple values. Now let me clear this test value and we can see how to use it in our own application. What we want to do is remember the date of birth entered by the user. Now, we could use the local storage API directly in this app component, but it's better if we keep that kind of logic separate. At the moment, we use the useState hook to keep the birth date in the component state. Wouldn't it be nice if we had a React hook that works like useState, but also saves the value to local storage? Well, that's exactly what we're going to do. We'll write our own custom hook. Let's create a new file called hooks.js. Here we're going to import the useState hook from React, because our own hook will be based on useState but add some more functionality on top of it. Now, a custom React hook is simply a function with a name that by convention starts with use. Our hook keeps values in local storage, so let's call it useLocalStorage. When using this hook, we want to pass a key, that's the local storage key for the item, and then we can pass a default value, that is the value to use if there is nothing stored in local storage yet. Now, we want our hook to be used just like useState, except for the extra key parameter. So let's start by simply wrapping the functionality provided by useState. We call useState passing the default value, and we return an array with the current value and a function to update the value, just like useState. If we save this file, we can go to app.js, import our custom hook, that is useLocalStorage, from hooks in the same folder. And now we can use useLocalStorage pretty much in the same way as useState. So we can replace useState with useLocalStorage. The only difference is that we need to pass an extra argument that is the key to use when saving the value to local storage. And we can call it birth date. If we save at this point, our application should work exactly as before, because our custom hook just calls useState at the moment. We can set a date of birth, but it gets reset if we reload the page. Now let's finish our custom hook implementation. In addition to calling useState, we want to persist the value. That means that our initial value will be the value we read from local storage under the given key. So if we previously saved a value, we'll use that one. But what if we haven't saved anything yet? In that case, getItem returns null, as it says in its documentation. So in that case, we'll use the default value supplied as an argument to our hook. The double question mark is the nullish coalescing operator if you haven't used it before. It means if the previous expression is null or undefined, then use the second expression. So this is the initial value we want to pass to useState. If there was a value saved in local storage, then we'll use that one. Next, we'll need to actually save the value to local storage somehow. And to do that, we'll need our own function. Let's call it setAndStoreValue. Here we take the new value, and we call setValue, that is the function returned by useState, so it will update the value in the component state. But additionally, we save the value into local storage by calling setItem with the key and the new value. At this point, we can return our own setAndStoreValue function. So whenever the component code calls this setter function, we'll do whatever useState does, but also save it to local storage. Okay, let's save everything and go and test if it works. If we select a date of birth, I'll just pick a random year. We see the selected date in the input box as usual. But if we go and look at the local storage, we can see our selected date under the birth date key. So it's also being saved. Let's show the console again. And let's see what happens if we reload the page. It remembered the date of birth we previously selected. So that's working as expected. Let's try selecting another date as well. So we have the 25th of May now. And if we reload the app, it's still the 25th of May. Good. It's nice not to have to enter the date of birth every time, even just for development. There's just one more thing I need to mention. At the moment, this code is reading from local storage every time this hook is called, which typically means every time the component is re-rendered. This is not ideal. It would be better to read from local storage only once. We can do that by turning our initial value into a function that returns the value. Let's change the name as well to make it clearer that it's a function. So when we call useState, instead of a value, we can pass a function. And this way, useState will only call the function once, when it initializes a value for a component, rather than every time the component is re-rendered. This is just to make our code more efficient. Let's do another quick test to make sure everything still works. If we refresh the page, the date of birth is still there. Okay, so what we've seen in this video shows two things really. First, we can use local storage if we need to store small amounts of data in our application. And second, we can write custom hooks to keep reusable logic outside of UI components. We wrote a custom hook to save the birth date into local storage so it persists across app reloads. And with this feature, our app is fairly functional. It does show the biorhythms, which is its purpose. It doesn't force the user to enter their date of birth every time, but it still looks quite bland. If we take a look at the online calculator again, you can see that it also shows a graph plotting the biorhythms over some time. Could we do the same in our own app? Well, if we look at the Ionic documentation, there's actually nothing about drawing charts. Ionic does not have a chart component or similar. But that's not a problem. Since ultimately we are working with regular web technologies, we can use any charting library designed for the web, like D3.js, for example. For this project, we're going to use Recharts, that is a library for React based on some D3.js modules. If we look at the examples, the first one is a simple line chart that already shows pretty much all the features we need to plot a biorhythms chart. So let's go and see how to use Recharts in our application. As usual, we'll first need to install an npm package. So let's stop the dev server and run npm install Recharts. Now we have Recharts in our project. Let's start the dev server again, which takes a little while. Okay, now let's go back to our code. Let me just rearrange the editor. We want to display a chart inside this Biorhythm Card component. But drawing a chart requires a fair amount of code, so let's create a separate component. Let's call it Biorhythm Chart. And this will be a React function component, so I'll use my snippet to generate the initial code. Now we can go and import this into our Biorhythm card. So import Biorhythm Chart from the module with the same name. And we can insert this biorhythm chart inside the IonCard content element. If we save these changes now, we can see the biorhythms chart's placeholder above the physical, emotional, and intellectual numbers. Now let's go back to our biorhythm chart. And here we'll need to import quite a few components from Recharts. The first thing we need is a responsive container. As the name suggests, this is just a container, and we want to wrap everything in it. What it does is it allows to specify some dimensions. So we can say we want the chart to take up the full width of the page. As for the height, let's set it to 200 pixels. Next, we want to add the actual chart. That is a line chart component, and put it inside the container. If we save at this point, we should see that the chart is taking up some space in the page, even though it's still all blank. To actually draw something, we'll need some data, and let's start by creating some mock data. It's important to understand how to structure this data before we try to use it with real biorhythm values. So data is an array that will contain one object for each data point. And in our case, we want each object to contain these biorhythm properties. So let's copy and paste them into our data. But of course, we'll also need some values for each of these properties. So I'll just make up some numbers for physical, emotional, and intellectual. Now, this is just one data point, but to draw a line, we'll need more than one point. So let's duplicate these objects and put some different numbers for the second data point, and same for the last one. We want different values, otherwise we'll just see a flat line. Also, each object in this array represents the biorhythms for a different day, so we'll need to calculate the biorhythms for multiple days to display the chart. Okay, so we have some data. Now we can pass it as a prop to line chart. The prop is called data as well. Next, we want to draw a line, and I'll auto-import this component from Recharts. We need to tell this line which property of our data elements to display. That's a prop called data key. For example, each object in our data has a physical property, so we can tell this line to plot the physical values. And if we save this file, we should see a line on the screen. The 3 points on that line correspond to the physical values in our data, that are 0.99, 0.37, and minus 0.10. Okay, in the same way, we can add another 2 lines to plot the emotional and intellectual values. And we should see 3 lines on the screen. However, it's not easy to tell which line is which, because they all have the same color. So let's add some styling. We can set the stroke attribute with a color to use for this line. Let's use green for physical, red for the emotional line, and intellectual will be blue. Let's see how it looks now. That's a lot better. So this is good progress. We have 3 lines for our 3 biorhythms. Let's add some more elements to the chart. We may want to draw an x-axis. That means a horizontal line at the base. Let's see what it looks like. We can see the x-axis, and it shows 3 ticks with 0, 1, and 2. Now, where do those numbers come from? Well, 0, 1, and 2 are simply the indexes of each element in the array. If we want to display something more meaningful, then we need to add another property to our data. In our case, we probably want a date property representing the day for which the values in each object were calculated. Obviously, each element will have a different date. Once we have such a property, that won't make any immediate change, but we can tell the x-axis to use the date as its data key. And now we should hopefully see the dates on the horizontal axis. We just see the last date actually, but I think that's just because there's not enough space on the screen. If we have a larger page, then we should see the other dates as well. Well, at least we see 2 of them now. Anyway, we'll tweak the appearance later. Let's stop here for this video. We've seen how to use Recharts to draw a line chart. We are using some mock data at the moment, but in the next video we'll make it work with the real biorhythm values. So we have an initial chart with 3 lines showing the biorhythms over time, but at the moment we're just using mock data. It's time to think about how we can display real biorhythm values. If we look at our calculations file, here we have a function called calculate biorhythms that returns the physical, emotional, and intellectual values for a single target date. For the chart, we'll need another function that returns the biorhythms for multiple days. Let's call it calculate biorhythm series. And instead of passing a single target date, we could pass a start date along with a size parameter, meaning the size of the series or how many days to return. So in this function, we basically need to call calculate biorhythms repeatedly for every day between the start date and size days afterwards. And we'll want to aggregate all the results into an array. That is what we return from this function. So this series array should have the same structure as the mock data we used in our chart so far, but with real values. Now, to process multiple days, we want to begin with a start day, that is the start date isostring converted into a Day.js object. And we may also want to take the start of the day to remove any possible time part from the date. Next, we want to iterate with an index variable that goes from 0 to size, incrementing by 1. Now we can calculate each target day, that will be the start day, plus I days, using the add method we've seen when we first looked at the Day.js library. Now that we have the target day, we can calculate the biorhythms for that day by calling our calculate biorhythms function. And here we need to pass the birth date and the target date. But the target date should be an isostring, not a Day.js object. So let's convert this into a target date that's an isostring. Then we can pass it to calculate biorhythms. Now, what do we do with the value returned here? We want to add it to the series array. This way, our series should contain one object for each day, with the physical, emotional, and intellectual biorhythm values. Let's save and go and use this function in the biorhythm chart component. We need to import the new function first, that is, calculate biorhythm series from /calculations, because it's in the parent folder, and we can call this function before rendering the component. However, we'll also need some props here, because at the moment we don't have the birth date and the target date that we'll need to pass as arguments to calculate the biorhythms. Now, we'll also need to pass these props down from the biorhythm card. Here we already have the birth date, so let's pass it down to biorhythm chart, and then do the same for the target date. Let's save this file and go back to the chart. So now that we have the dates, we can call calculate biorhythm series, passing the birth date, and we cannot pass the target date as it is actually. We'll need to calculate a start date. So let's import the Day.js library, and then we can use it to calculate a start date. Here we want to parse the target date. Now, let's say we want a series of biorhythms that covers about a month, and the target date will be at the center of this period. So what we can do is subtract, say, 15 days from the target date, because we want to take a period that starts 15 days before the target date and ends 15 days after the target date. We also want the start date to be an ISO string, so we can pass it to our function. And finally, we need to pass the size of our data series. Now, we said we want 15 days before the target date, 15 days after, plus the target date itself. That makes it 31 days in total. So we'll get back an array with 31 elements, and this will be the data for our chart, which means we can now remove the mock data we created just to learn how to use Recharts. All right, it's time to save and see what happens. That's pretty good. We can clearly see the biorhythm waves. There are a few things we can improve. For example, it may be better to show just the lines without all those dots. We can easily remove the dots by setting dot to false on every line element. That's cleaner. I don't know how well you can see it in the video, but it seems to me the lines are not very smooth. I can notice a small angle at the top of the green curve, for example. We can make the line smoother by setting the type attribute, and natural is one of the options. They should make the curve smoother by using interpolation. Looks good. Let me just split this code into separate lines and collapse the imports as well. Now, there's something missing in our chart. If you look at the x-axis, there are no labels. We used to show the dates there, but the data we're returning at the moment doesn't have dates. Each object only has physical, emotional, and intellectual properties. So let's add a date that can be the same target date passed as argument. All right, let's save and see what happens now. There is one date on the x-axis, but it's only the last one. Also, it's displayed as the full ISO string. So first of all, we want to format those dates in a nicer way. Let's write a function to format the date. Here we take the ISO string and we return the same date, but formatted with Day.js. Let's just show the day and the month. We want to keep it short because it will be displayed on the x-axis, so I'll leave the year out. Now we can take the array returned by calculate biorhythm series and transform each item using the map function. We want to return an object with all the same properties as the original item, but overriding the date property to be the original date but formatted with our new function. Right, let's see what this does. Okay, we can see a few dates on the horizontal axis now, and they are short and readable. Something else we could do is show a vertical line over the target date, because at the moment it's not that clear when looking at the chart where today's date is. We can do that by adding another Recharts element that's called a reference line. And on this component, we can set an x attribute, which means at which point on the x-axis we want to draw this line. Here we can take the central element in our data array. Remember that the array has 31 elements centered around the target date, so the 15th element corresponds to the target date itself. And we want to take the date property of that element, because the date is the data key of the x-axis, so we need to use the same property for the reference line. If we save now, we can see a vertical line in the middle of the chart. So that's where the target date is, and it lets the user see where they are with their biorhythms. It's just a shame that the dates on the x-axis don't include the 19th of February, that is the target date. But we can change that as well if we want to. All those indicators displayed on the x-axis are called ticks. And if we don't like what Recharts does by default, we can explicitly pass an array with the points where we want to show a tick. So if here we pass a single element with the date of the object at index 15, like for the reference line, then we see a single tick with the label 19th of February. That's good, but it would be nice to show some other dates as well, otherwise it's not clear which period of time is covered by the chart. So we could display the first date and the last date. The last index is 30 because the size is 31, but array indexes are 0 based. Okay, let's try this way. Now we can see the last date, but not the first one. I guess we need to pick an index that's not the very first, otherwise there's not enough room on the left side for Recharts to show the label. Let's try with index 3, that is the fourth element. And to keep the symmetry, we may want to subtract 3 from this index, so take the fourth from the end. Okay, that looks good. At least now we get an idea of the time period displayed in the chart. As a final touch, I want to add a Cartesian grid component, which you'll see in a second what it does. It's easier to show than to explain. So it's a grid of lines. But actually, I don't want the vertical lines, so let's set vertical to false. Also, I'd like them to be dashed lines, so I'll set stroke-array to 3, 3, which means draw the line for 3 pixels, then skip 3 pixels and repeat. Okay, I think this looks pretty good now. The Cartesian grid makes it easier to see the biorhythm values. The top line is 1, the middle is 0, and the bottom is -1. So for example, you can see that the blue line on the 19th of February has a value slightly above -0.5. Of course, we can also change the target date if we want to see what our biorhythms will be in a few days. And you can see that the chart updates with a nice animation effect, where the lines appear to move into their new position. Let's do a final test to make sure the chart looks good in an Android device with a small screen, and on an iOS device as well. Okay, that's our nice biorhythm chart done. It was a bit of a long video, but I hope you enjoyed it. Drawing charts is a fairly common requirement. Here we plotted some biorhythms, but you could follow similar steps to create revenue or price graphs or many kinds of business graphics. All right, we have a nice chart showing the 3 biorhythm lines over time. However, at the moment it's not easy to tell which line is which, because each line has a different color, but the text below with the biorhythm values is all in gray. We could write each row of text in the same color as the corresponding line in the chart. For example, since in the biorhythm chart the line for the emotional biorhythm uses a red stroke, we could use red for the text with the emotional value as well. The quick and dirty way to do that would be to add an inline style and just set the color of this paragraph to red like this. This works, but using inline styles is not a good practice, because this way our styles are not reusable on other elements. A better approach is to add a CSS class to this element. Let's call it emotional. But then we'll need to write some CSS rules somewhere. So how does that work exactly? Remember that our project was initially generated with Create React App. So the Create React App documentation applies here. If we look at styles and assets, there's a page about adding a style sheet. Basically, we can just write a CSS file, import it into the component file, and make sure the class name matches the rules. But this is not the only option. We could also use CSS modules that will ensure all the styles are locally scoped to our component. In this case, you import the styles from a module.css file as a JavaScript object. And in addition to plain CSS, you can also use the Sass preprocessor if you like, that is SCSS files. Now, I won't go into the details of each possible approach, because this stuff applies to all React apps, not just Ionic. But I wanted to make you aware of the options so you can read more in this documentation if you like. For our project, we'll use the simplest approach, that is regular CSS files. So let's go back to our application. And we want to add some styles for the Biorhythm Card component. So let's create a new file called biorhythmcard.css. Then we need to import this new CSS file in the component. So import biorhythmcard.css. Note how for CSS files we need to specify the extension, unlike for JavaScript files. Now we can save this, and in the CSS file we can add some styles. In the component code we use the class called emotional, so let's add a CSS selector matching that class. And here we can simply set the text color to red. If we save, the text with emotional turns red. So that works. Now, the risk with this approach is that this rule will match any elements with an emotional CSS class anywhere in our application, not just inside the Biorhythm Card component. For this small application, it's unlikely to actually be an issue. But one way to avoid that problem is to wrap the entire component in a CSS class with the same name as the component itself, and then use this class in all the CSS rules for this component. Personally, I prefer changing the class name to use the same case style as the other CSS classes, but that's not strictly necessary. Now, once we have this class on the root element of this component, we can modify our CSS selector to match only elements with the emotional class that are inside the element with class Biorhythm Card. And the result is the same. But like I said, this makes it less likely that you accidentally apply a style to some other component in another part of the app. Now, since we are dealing with CSS, we can use the Chrome Developer Tools to inspect the styles on our page. If we use the inspection tool, we can select the paragraph we're interested in, and we can see that it has class emotional, and it's matching the CSS rule we just defined, so the color red is applied. Incidentally, we're not limited to adding our own styles. We can also override some of the ionic styles if we want to. For example, there's maybe a bit too much space at the moment between each line of the text inside the card. That's because Ionic sets the line height of a paragraph to 1.5 when it's inside a card content. We can change that by defining our own rule, saying that for p elements inside a biorhythm card, the line height should be normal. And if we save, there's less spacing between each line of text now. So we can easily override any ionic style because it's all done using CSS at the end of the day. Also, this example shows the advantage of wrapping the component in its own CSS class. Without the Biorhythm Card class, this new rule would apply to all paragraphs anywhere in the app, which is probably not what we want. Anyway, let's go and finish styling our biorhythm values. In addition to emotional, we have a physical biorhythm, and to match the chart, this should be green. Then we want an intellectual class with the color set to blue. Note that nothing changed after we saved. That's because we only added the CSS class to the emotional paragraph so far. Let's do the same for the other two paragraphs and change the class names accordingly. Let's save, and we should see the right colors everywhere. Good. Now you can clearly tell which line in the chart corresponds to which biorhythm. And this serves as a simple example of how to add some styling to a specific component. In the previous step, we added some styling so that the text displayed below the chart matches the colors used for drawing the lines in the chart, like red for the emotional biorhythm. However, now we have this situation where we're using CSS for styling the text, but for the chart line, we're applying the color directly in the component code. Could we style the chart line using CSS as well? Let's use the dev tools to inspect the chart line. Inside the IonCard content, there's a dev with class Recharts responsive container. And if we look inside, there's another wrapper dev, and then there's an SVG element. So the chart is drawn using SVG, or Scalable Vector Graphics. Inside the SVG, we can see some elements with class Recharts line. So these correspond to the line components in our code. The tag of these elements is G, which is an SVG group. Now, if we expand the second Recharts line, that should be the emotional one, the group contains a path, that's what draws the line, and it has stroke set to red. So now that we know the structure of the DOM elements rendered by Recharts, we can style them using CSS. Let's add a new file called biorhythmchart.css, and then we want to import this new file into the biorhythm chart component. So let's import biorhythmchart.css. Following the same approach we used for the card component, we want to add a class name to the top-level element with the same name as the component, but all lowercase for consistency. We'll use this class name to limit the scope of our CSS rules. But before we do that, we want to remove the red stroke configuration and replace it with a CSS class. Let's call it emotional like we did in the card component. Now we can use this top-level CSS class in the CSS selector combined with the emotional class. And we want to apply the styles to the path element inside it. If you remember, when we inspected the elements, the line component is rendered as a G element. That's the one that will have our emotional class. But then inside the G, there is a path. That's what actually draws the line. So the path for an emotional line should have the stroke set to red. Now, before I save, notice how in the chart at the moment there is no red line. Since we removed the stroke attribute from the component code, Recharts is just using the default color for the line, which seems to be light blue. If I save now, you can immediately see the line becoming red again. Okay, so the style is working, and we could repeat the same process for the other two lines as well, but before we do that, let's think about duplication. At the moment, in the card styles, we set the text color to red, and then in the biorhythm chart style, we set the path stroke to red. So we have the red value in two different places. Since we want the text color to be exactly the same as the line color, it would be nice to define this red in a single place and then reuse it. So what we're going to do is use a CSS variable for that color. Remember that in index.js we import all the Ionic CSS files. We can add our own global CSS file. Let's call it index.css. And we want to import it into index.js, so it will apply to our entire application. In this new style sheet, we can define some CSS variables that apply to the root scope. Remember that CSS variables start with --. Let's call this one emotional color, and its value is red. Maybe we could prefix all our variables and call them app something, just to avoid name conflicts. We know that all Ionic variables start with ion, so if we use app everywhere, that should make it clear that they're our own custom variables. Now we want to go and use this variable in our biorhythm chart styles. So instead of red, we'll use var and the name of our variable. And if we save, nothing should change. The line should still be red. Okay, now we can do the same for the biorhythm card styles. Instead of using red, we use our emotional color var. And again, the text on the page is still red. Now, to prove that it's actually using the color from our global CSS variable, let's go back to index.css and try selecting a different color. If instead of red, we pick some yellow color, for example, just to make the difference obvious, if we save the new color, you can see that it's applied to both the line in the chart and the text below. So that's working as expected. Now, yellow is obviously a horrible choice, so let's revert it to red. And let's define the other colors as well for the other biorhythms. So we need a physical color, that's green, and then an intellectual color, that is currently blue. Now we need to go and use these variables. Let's start with the card. Replace the physical color and do the same for intellectual as well. Just need to change the name. Finally, we want to repeat the same process for the biorhythm chart as well. Here we still need to write the rules for the other two. Physical will use the physical color, and intellectual will use the intellectual color. Voila! Are we missing something? I think we still need to set some class names in the chart component actually. Let's replace the stroke with a CSS class everywhere and set the appropriate class names. There you go. That should be everything. We now have all the colors in a single place. So maybe we can pick some darker shade of green, for example. It's not that different, but a bit less saturated. We can do the same for the others, just to have some different shades rather than using the basic colors. So that's a darker red, and we can pick a darker shade of blue as well. Okay, I think that's enough. We've seen how to use CSS variables to reuse style values across our application. There are other ways to do that, like using the Sass preprocessor if you're familiar with it, but CSS variables work well enough and don't require extra setup.